when we look in here, we've got still our SCL demo program, and we've got these two templates up here for these two loops, for and while. So let me just show you how these work. It's real simple. I clicked on a for loop, and here comes some alphabet soup. If you've already done programming, you're going to look at this and say, man, I could do that in my sleep. If you've never done computer programming, you're going to look at this and be like, what? Counter, we just need to define a local tag, a local variable. So I'll do something simple and traditional, and I'll call it lowercase I. Let's define tag. We can't use temp for this. This definitely needs to be local static. It'll be an int, and it's defined. So we're going to be counting. Let's pretend we want something to happen, like 100 times. So we'll say from 0 to 99. Okay, so that's going to do something over and over again 100 times. And what do we want to do? Maybe we'll do something like add 3 to val 1, just to be simple. So I'm going to just select all of this, and we'll say val 1 colon equals val 1 plus 3 semicolon. Okay, so we're just going to be adding 3 to that over and over and over again. And this is going to happen very, very, very quickly. So once we start this program, instantly that val 1 is going to just jump through the roof, and it's going to be at 300 or whatever. So why don't we put some conditions on this? We're going to say if, and remember we have our switch, right? If switch and not, and remember we had our little set bit, or I don't remember what we called that. It was like an alarm set or something. We'll just call it, actually I'll create a new one, so we'll say loop set. And not loop set, then, and let's define this loop set as, that's going to be a bool, so I'm just going to type a B there, and that's going to be local static. Define it. So let's select all of that and hit tab just to space it over, and right here is where we will set the bit, our little loop set. So we'll say loop set colon equals 1 semicolon, and then we'll come down here and end underscore if semicolon. Alright, so now we've got our for loop nestled inside of this if statement. And what this if statement is doing is, one, it's allowing us to tell this loop when to execute based on us toggling this switch. And also, it's making sure that this loop only happens one time. And that's what this loop set here is doing. That's basically acting like a one-shot. And I'm also going to show you a second kind of loop. So I'm going to come up here and click this while loop. See, what this for loop is going to do is that's going to use this little lowercase I that I created, which is an integer. It's going to start off by defining that, giving it a value of 0, and then it's going to do whatever's in the middle of this. Then it's going to add 1 to that value, and then it's going to come back and do it again, and it's going to keep going until this thing equals something over 99. Then it's going to end itself, and it's going to proceed and keep flowing with the rest of the program. And something else that I can do is, instead of counting by ones, I can come up here and add by 2, for instance. And now this will count by 2's, okay? So there is some elaboration that you can do with these, but for now, let's just have it count by 1's. And that's going to add 3 each time, and so we'll end up with, that as our val 1. Then we have this while loop here. And let me show you how while works. While, and now we give it some condition, or conditions, which is going to equate to true or false. And once this thing is true, then it's going to do whatever this thing is. And it's going to keep doing this over and over and over forever until this condition becomes false. Okay? So let's play with that. We're going to say while. Let's try val 2 is less than, let's give it a number like 6,000. While val 2 is less than 6,000, now we're going to come down here and do something. So we're going to say val 2 colon equals, that's an assignment, setting it equal to val 2 plus 1 semicolon. So now, as long as val 2 is less than 6,000, this loop is going to run over and over and over again, adding 1 to val 2 every time. And once it gets up to 6,000 or something greater than 6,000, then it's going to stop. Now, we've got a couple of things here. I want to go ahead and put this loop inside of an if statement as well. That's just something I'm doing for test, okay? So that's not something that, you always have to do. You can have a loop statement sitting here just like this. That's not a problem. But I want something that I can turn on and turn off, okay? So let's give ourselves a switch to, and right click, define tag. That's going to be global memory, and it's going to be Boolean. Okay? Alright, so if switch to and not loop set to, then, and let's right click on our loop set to, that's going to be local static and a bool. Define. Let's select our loop here and tab just to give it some indenture. And then end underscore if semicolon. And we also need to give ourselves that loop set here. So we're going to take our loop set 2 and colon equals 1. That way this loop is only going to run one time. And then as far as our loop set and our loop set 2, we need a way to reinitialize those. So if reset, and yeah, we've got a global memory set up as reset, then, and we're going to say loop set. Let's take that first one, colon equals 0, semicolon, and our second loop set, colon equals 0, semicolon, and end underscore if semicolon. Okay, so now we've got a way to reset those using our reset. So we need to monitor switch to, val 1, val 2, and our reset. So let's go back to our watch table, and I'm just going to select all of these, right click delete, and let's redefine stuff. So what do we want first? We want our switch, and it's not coming up, so there we go, switch, And then we want our switch 2. We want our val 1. We want val 2. And we want reset. Okay, I think we've got all of this together. So let's go back into here and download this to the processor. And it's saying, hey, your data blocks are going to be reinitialized if you do this because you've made some pretty gross changes to your program. And we say that's totally fine. This program's junky anyway. Alright, so everything's in. We're up and running. Let's go back to our watch table. And remember, our for loop is controlled by this switch. And that's controlling val 1, and it's going to go round and round in circles, adding 3 to that every time. So why don't we start by just initializing those two values and setting those both equal to 0. And whoops, there we go. Come on. And for whatever reason, it doesn't seem to want to let me set that. So let's try and set. Okay, there we go. So they both went to 0. And I'll delete those out so I don't accidentally set them again. Let's toggle our switch. So we're going to go ahead and plug that value in right here. And you see how quickly that thing jumped up to 300? That's how quickly that loop iterated itself 100 times. And we'll do the same thing for loop 2 or switch 2. It looks like that already ran independently of the switch, and I thought we put a switch on that program. Let's go back and look at that guy. If switch 2 and not loop set 2, and we didn't have loop set 2, but we never had switch 2, so it looks like that hasn't run. I think we're just getting something wonky with our values. So let's go back into that watch table 2. And here we go. Let's put a 0 into val 2. And let's send that in. Okay. And very quickly that popped up to 6,000 because we already had our switch set. So let's try that again. We're going to reset everything. There we go. So val 2 is set to 0. And let's go ahead and pop that switch to true. And one click and oh, we didn't reset it. So that's why it's not going to run again. Remember, we've got that loop set that we've got to reset. So let's try that again. We're going to run our reset this time. Okay, so now that's reset. And let's clear these conditions out. So all gone. Okay, and now let's reset our true. Clear out the condition. Now we want to look for val 2 to jump. So set that to true, our switch 2, and boom, pops right up to 6,000. The only reason val 1 moved is because, remember, we've got val 1 and val 2 overlapping each other in the memory register. So not the end of the world. But jumping back into our program, that is what a while loop looks like, and that is what a for loop looks like. So if we want to, just for aesthetic's sake, go ahead and get rid of these if statements all over the place, and there we go. That is what a basic for statement looks like. Remember, we've got one statement nested into here, but we could have all kinds of things stuck into there. The same thing for this while statement. We're looking at a condition inside, but we don't even have to have a condition inside. We could have this like while some input is energized on our PLC, then something completely independently will just keep happening over and over again until we lose that input, then the computer will resume scanning.